This is section 9.7 in Algebra 2. It's all about exponential graphs. Okay, so we know several parent functions from, I don't know, earlier this semester. For example, we know that parabolas have the parent function y equals x squared, or that the square root graphs, we said, oh, the graph just looks like this. Or we talked about rational functions. Remember the 1 over x graphs that have two pieces to them, something like that. Okay, so we've got all these different parent functions. And now that we've talked about exponential and log functions, we're going to talk about those parent functions. Okay, so an exponential graph, we're going to think of it like this. It'll be y equals, you're going to have some base, and then it's going to have some exponent. So for example, if I'm looking at y equals 3 to the x, so the base is 3, the exponent is x. That's not 3 times x, that's 3 with an exponent of x. Okay, so this is going to look like this. So first of all, let's develop what this parent function is going to look like. In the old days, when we first learned to graph, we would do these little xy charts. Okay, so this is saying, let's just pick some numbers randomly. So what if x equals 0, right? If I put in a 0 for x, then y is going to be whatever 3 to the 0 is, which we know anything to the 0 is 1. Okay, what if x is 1? Well, then according to that equation, y would equal 3 to the first, because notice we're just putting a 1 in place of x, and that would be 3. What about 2? Well, y would be 3 squared, so we know that's 9. What about, let's do some negative numbers. Like, what if we have x to be -1? Well, if that's the case, I've got 3 to the -1. And remember, we know exponents mean it's just a fraction, so that would be 1/3. Or what about -2? Well, if my exponent were -2, isn't that the same as saying 1 over 3 squared, which we know to be 1/9? Okay, so let's hold it right there. So that means I have several ordered pairs, right? I've got the ordered pair 0, 1, so I'll put that right there. I've got the ordered pair 1, 3, so 1, 3, just putting these points on. I'll put on the point 2, 9, so 2, let's see, 3, 4, 5, 6, 7, 8. I know it goes off, but 9 would be like right up here. And then at -1, the y value is 1/3, so we're just going to kind of guesstimate what 1/3 would be. And at -2, the y value is 1/9, so that means it's just barely above the x-axis. And so if we were to kind of connect those, the graph would look something like this. Goes through those points, something like that. Okay, so do all of these exponential functions look like that? Well, let's do one more. Instead of 3 to the x, what if we take 2 to the x? In other words, if the base is different, is it going to be a different graph? Well, you would think, let's try that. Let's do the same thing. If x equals 0, then 2 to the 0 is 1. If x equals 1, I'm going to have 2 to the first. If x equals 2, I'd have 2 squared. Let's go one more. If x equals 3, I would have 2 to the third, which is 8. And let's do some negative numbers like we did above. What if I have -1? That'd be 2 to the -1, which is 1/2. Or if x is -2, that would be 2 to the -2, which remember is 1 over 2 squared, so 1/4. Okay, so again, let's think of all of these as ordered pairs. So 0, 1, well, that's the same. 1, 2, well, that's not the exact same point. 2, 4. I'm going to keep putting these on. 3, 8, I think goes right to the top. And then our negative numbers, -1, 1/2. Again, we'll just kind of estimate. And -2, 1/4. So if you compare, even though they're not all the exact same points, do you see that it kind of gives me the same basic shape? So let's see, what do these things have in common? Look at the next line. It says, note what happens on the graph above the x-axis. Well, think about right, not just necessarily above the x-axis, but right at the x-axis. Do you see that this graph kind of levels off at the x-axis? This graph kind of levels off at the x-axis. So let's just say the graph levels off. Now, you may remember from a while back, what does it mean when the graph levels off? Isn't that saying that there's a horizontal asymptote? We'll develop that a little bit more in a minute. Okay, in both graphs above, the y-intercept is what? Well, y-intercept, remember, is where it crosses the y-axis. So on this one, it crossed right there at 1. On the graph up here, it crossed right there at 1. So in both cases, that was the one point that was exactly the same. So the y-intercept is 1. And will this always be true of exponential functions of this form? Well, the ones we did, it was the same. So think about it. If I have an exponential function, let's say I have 10 to the x. If x is 0, then will the y value always be 1? Yes, because anytime the exponent is 0, then the answer is 1. So the answer here is yes. These are always going to go through the point 0, 1. Okay? So let's look at this then. So if that's the case, if we said up above they have the same basic shape, then is there any difference in the exponential functions based on the base? So like the first one has a base of 2. This second equation we're looking at has a base of 5. And this third equation that we're looking at has a base of 10. Well, these are the 3 different graphs. And actually, I've color-coded here for you. So the blue graph, when I put it in my calculator, that was the graph of 2 to the x. The green graph, that was the graph of 5 to the x. And the red graph, that was the graph of 10 to the x. So is there a difference? Yes, slightly, but not a huge difference, right? So what do we notice about the similarities? Well, we could say, let's see here. We could say they all have same basic shape. I'm not saying that there aren't any slight differences, but it's the same basic shape. We could say they all go through that same y-intercept, right? 0, 1. Doesn't every single one of those go through that point right there at 1? Okay. And then the last thing I'm going to say is notice all of the graphs as you go out to the left, they level off at the x-axis. So all level off at the x-axis. So what does that mean? That means there's a horizontal asymptote on the x-axis. Well, what's the equation of the x-axis? Well, remember, if it's a horizontal line, it's y equals, and on the x-axis, I think we can agree y equals 0. So the basic parent function has a horizontal asymptote right there at y equals 0. What we could say is, I'm going to draw in the asymptote. We could say that here's the horizontal asymptote where all of those graphs level off. Okay, so number 3, it says sketch each of the graphs below without a calculator. All right, it's kind of a trick question because like we just said, it doesn't matter if it's 5 to the x, 2 to the x, 3 to the x, 10 to the x, it's always going to go through the point 0, 1. It's always going to level off right here at the x-axis. And they're all going to have that same basic shape where they level off right there and then they kind of shoot straight up. Well, not straight up, but almost straight up. Okay, so is number 4 here any different? What if the base is 8.34? Who cares? Doesn't matter if it's a decimal, whole number, whatever. If that has an exponent of x, then I know it goes through the y-axis at 1. I know it's going to level off down here on the x-axis. And it's going to have the same basic shape. Okay? So is that it? Is that all there is to know? It's just the basic parent function? Okay, well, that's the parent function. So what might we do with these functions? Well, what did we do with all of the other parent functions? Didn't we move them up or down or left or right or flip them around? So let's kind of generalize. So our basic parent function for exponential is going to be y equals some number that we call the base with an exponent of x. 2 to the x, 3 to the x, 5 to the x, it doesn't matter. So in this example below, the parent function that we're thinking about, because the base is 2, is 2 to the x. Okay, But think about what you know of transformations from the old days. If there's a -1 out at the end, doesn't that shift it up or down? In this case, isn't it going to shift 1 down? And then normally we would say, hey, if there's a number in the parentheses. Well, in this case, there's not a parentheses drawn, but do you see that this x plus 3 is, let me make this a little bit bigger, the x plus 3 is the exponent. So there's kind of this implied parentheses around that x plus 3. You don't have to write it in to show that the entire x plus 3 is the parenthesis. So that means that plus 3 is going to shift it 3 to the right or left. Well, remember, it's the opposite of what you would think. So it's going to shift 3 to the left. Okay. Now, before we write down the horizontal asymptote, let's just think about this graph. Okay. So first of all, let me just to get us to be thinking about the basic parent function. So the basic parent function has a shape something like this, right? That's my basic parent function for 2 to the x, 3 to the x, whatever. Okay, so I'm going to take that point, that key point, which is right here at the y-intercept. I'm going to take that point. I'm going to move it 3 to the left, and at the same time, 1 down. 1, 2, 3 to the left, and 1 down. So that point that used to be the y-intercept has now just moved to the left and down. So I'm going to take the shape that used to be this shape right here. So remember, this is the shape. That was my basic parent function. I'm going to take that shape and I'm going to move it over and down. Okay. So there it is. I just moved it to the left and down. And so where's my asymptote now? Well, does it make sense that if the asymptote used to be here and I moved the whole thing down 1, doesn't that mean my asymptote now is right here? So the asymptote now is y equals -1. I want to point something out. It's not a coincidence that this number is always going to be the same as that number. Because think about it. If the graph is moved up or down, then doesn't that mean that the asymptote that used to be at 0 is going to get moved up or down? So that's kind of a helpful hint for exponential graphs. You'll always know what the horizontal asymptote is based on that number out at the end that moves the whole graph up or down. So let's just do a quick reminder of what we know about transformations, about moving graphs up or down or left or right. So remember, if you have a plus or minus c out at the end, then you're going to shift up or down, right? I'm sure you remember that. If that plus or minus c is on the inside, you're going to shift left or right. Again, I'm pretty sure, hopefully, we kind of remember that one. Remember, if the negative is out in front, what does that do? That flips it across the x-axis. Flip across x-axis. So just to remind you, like if I had the basic parabola, right, y equals x squared right there, if I put a negative out in front, if I think of it as -x squared, remember how now it's just going that direction, it's flipped across the x-axis? Okay, same thing is true for all the parent functions. And finally, we're going to add one that I don't think we've talked about yet, so I'll put this one in a different color because this one's kind of new. What if the negative is not out in front, but what if it's just on the x? Wherever the x might be, what if the negative is just on the x? Well, in that case, it doesn't flip across the x-axis, but what would you speculate? It's going to flip across the y-axis. I think we talked about that when we did the square root graph. So right back in the day, we learned the square root graph, right, is something like that. If we had put the negative out in front, right, negative out in front, we know that's going to flip it across the x-axis. But what if we had put the negative on the inside where the x is? Do you see the difference? Well, in that case, it's going to take what was the original square root graph, which is the blue one, right? There was your original square root graph. And I'm going to flip it across the y-axis, so it'll be going this direction. Okay? All the same thing is true on these basic exponential graphs. All right, so let's look at these. It says first graph the parent function and the transform, and then basically then move it around for each of the following. Make sure you show the horizontal asymptote. Well, you know what I think I'm going to do? I think I'm going to make this a little easier myself. I'm going to start by just putting on the horizontal asymptote. So remember we said the horizontal asymptote is just whatever this number is out at the end. So in this case, I know there's a horizontal asymptote at y equals 2. Or on number 2, so what is the number out here at the end? Well, if there's not a number out there at the end, that's like having it's kind of like having a plus 0. So that means the horizontal asymptote is right here at 0 or on the x-axis. And on number 3, I know the horizontal asymptote is going to be at 1. That just kind of helps me with my graph. So they said, think about the basic parent function. Okay, well, the basic parent function we know is the one that goes through right there at 0, 1, and it's this shape, right? That's the basic parent function. If I were just going to graph 4 to the x, it would be that graph. Okay, but what do I want to do? Well, I want to take that graph and move it up 2. So what used to be there at 1, if I move it up 2, is now right here at 3. And since you have your horizontal asymptote, that's going to help you know where this graph is going to level off. So that blue is the final graph. Okay. On number 2, again, remember the basic parent function is the one that goes this direction, right? All right. Well, what does that negative out in front do? Well, that flips the whole thing across the x-axis. So what used to be up here at positive 1 flips across is right here at negative 1. So just flipping it is going to have it go this direction. Do you see how that's just me flipping it across the x? And now what does that plus 1 do? Well, since it's up in the exponent, there's like this implied parenthesis. That means I'm going to move it to the left 1 unit. So that point that was right here on the y-axis, on the y-axis, I'm going to move it to the left 1. So it's that same basic shape, but it goes through that point. Now, I'm not saying you have to put all of this stuff on there. This is just me trying to get a lot of people to kind of see what's going on. So maybe I'll draw a little bit less on the next one. Okay, so maybe instead of drawing the full basic parent function, maybe I will just think about where it starts. Well, I know the basic parent function goes through the y-axis right there. That's going to be kind of my pivot point. That's going to be the point that I'm going to move up or down or right or left. Okay, because of that minus 2, I'm going to move it 2 to the right. And then because of the plus 1, I'm going to move it up 1. So that's the point that used to be on the y-axis. I know it's leveling off at that red horizontal asymptote. And I know the basic shape. So there it is. Okay, so it says find the domain and range for each of the graphs above. Okay, well, let's think about it. Remember, domain means left and right. Okay, so for number 1, look at the blue graph because that's my final. In fact, if it's helpful, maybe I'll get rid of that green one just so you're not confused by it. Okay, so look at that blue graph. How far to the left does that graph go? Well, doesn't it go all the way over to negative infinity? And how far to the right? So even though it shoots straight up, it's still gradually moving to the right, right? Gradually moving to the right. So it goes out to positive infinity. And keep in mind, this is left and right. I'm not saying positive infinity because the graph goes up. I'm saying positive infinity because the graph is gradually moving to the right. Okay. And then the range, well, what's the lowest that blue graph will ever be? Well, the lowest is going to be 2. But since it doesn't actually touch 2 because it's a horizontal asymptote, I'm going to use a parenthesis. And what that means is it's going to get really, really close to where y equals 2, but it's not going to touch it. And then how high does it go? It goes all the way up to infinity. Okay, look at number 2. Again, look at the blue graph. Don't let the green ones confuse you. That was just us kind of developing. So look at the blue graph. For the domain, how far to the left does that graph go? Well, it's going to go out to negative infinity. Okay. How far to the right? Now, don't be confused. You're going to want to say negative infinity because the graph is going down, but that's a y. Remember, the domain is from an x side to an x side. So as this graph continues out to the right, it's going to continue out to the right. So it's going to continue out to positive infinity. So it goes from negative infinity to positive infinity. And for the range, well, the highest it's going to be is the x-axis, which is 0. And the lowest it's going to be is negative infinity. So it goes from negative infinity all the way up to 0. Again, it doesn't touch 0 because it's a horizontal asymptote. And then number 3, okay, domain, how far to the left? Well, negative infinity. How far to the right? Even though it shoots up, it's gradually moving to the right, so it's going to positive infinity. For the range, the lowest is 1, but it doesn't touch 1, and the highest is infinity. So notice something here. The domain of every single one of these was negative infinity into positive infinity. That is always going to be true for exponential. Always. You don't even have to think about it, because these graphs always will go from far left to the far right. What's going to change on these exponential graphs is going to be the range. Okay? So let's put it all together here. Again, if I were you, I would put the horizontal asymptote on first. So because of this -3, I know there's a horizontal asymptote down here at -3. Number 5, notice there's no number out at the end, so that's how I know the horizontal asymptote is right here at 0. Again, no number at the end, so the horizontal asymptote is right here at 0. So that's how I know where my graph's going to level off. Okay. So number 4, so think about the basic parent function, right? It goes here and it goes this direction. That's just for us to think for a minute. That's the basic parent function. So what does that negative right there do? Well, that's the one that's on the inside on the x. It's not out in front. It's on the inside. So that's the one that's going to flip it across the y-axis. Well, if I flip it across the y-axis, it's still going through that point at 1. It's just coming this direction. Do you see that that's what it would look like if I flip it across the y? Okay, so I've just flipped it across the y, so there's where I am now. And then what does that -3 do? It moves that entire thing down 3. So the point that was right there at 1, if I move it down 3, now it's right here. So it makes sense that it's going to level off at that red horizontal asymptote. So there's my final graph. Okay, on number 5, think about the basic parent function goes here. It's going this direction, just so we can all kind of get it in our brain. That's the basic parent function. This time, the negative out in front is going to flip it across the x. Okay, think about across the x. So the point that was up there at +1 is now down here at -1, and it's going this direction. And since on this one, there's nothing else in the equation, it doesn't say to move it left or right or up or down, so that is my final graph. Okay? And then number 6, again, I like to get an idea in my brain of the basic parent function. There it is. Okay, so on this one, oh, look, it has a negative out in front and a negative on the x. That means not only are we going to flip it across the x, but we're also going to flip it across the y. Does it matter which one you do first? Not at all. Okay, so let's say I flip it across the x first, so that it's just like number 5 over there. So if I flip it across the x, it's now going this direction. Okay, so let me get rid of this just so you don't get confused. Okay, still has a horizontal asymptote right there at 0, right? Okay, and now let's do the fact that there's a negative up on the x. So if I take that graph and flip it across the y, it's still going to be going through that point right there at -1, but it's going to be going this direction. So that is going to be my final graph. And again, notice it still has the horizontal asymptote at 0. Okay, so that's kind of a summary of all things related to the new parent function that we just learned, the exponential graph.